All right, so a little bit more on 10.4. The question comes up is why do I have to check my answers? I solved it, my work is right, and these are my solutions. And it goes back to what I said the very first time we talked about solving radical equations, and it's that you may be able to solve it and get two solutions or even one solution, but they don't work in the problem. And when that happens, you have what's called an extraneous solution. You have an extra answer that doesn't work within the parameters of the equation you started with. Okay? I know that seems strange, but it is something that happens. So let's look at these real quick. We'll review a little bit on solving them, and then we'll check a couple, because that's going to happen here. So we've got the radical by itself like it's supposed to be. It started out that way. In order to get rid of that radical, we've learned that we have to square both sides. So on the left side, we get y plus 1. On the right side, we have y minus 1 times y minus 1. And so we end up with y squared minus 2y plus 1. This multiplication here goes back to Unit 5 when we multiplied polynomials. We have a y squared, so this means we're going to make it equal 0. So we're going to subtract 1y. We're going to subtract 1 from both sides. And you'll notice that every time I've done this, I've lined up the like terms on both sides of the equal sign. And I get 0 equals y squared minus 3y plus 0. Well, this plus 0 isn't needed, so now I have 0 equals y squared minus 3y. Some kids will use the quadratic formula because they're just that much in love with it and it's easy for them, which is perfectly fine. But I look at that problem and it goes back to factoring using a greatest common factor. So I'm going to take that problem and I'm going to write it as 0 equals y times y minus 3. Because y squared and 3y have a common factor of y. And then I'm going to solve using the zero product property. So I take one equation and I say 0 equals y. And I take the other equation and I say 0 equals y minus 3. So here I have one of my supposed solutions. And here's my other supposed solution. So we're supposed to have, it appears, two solutions to this problem, because as we solved it, we got a quadratic showing up. Reality check, do we really get to use both solutions? And that only is determined if you check your answer. So you have to go back to your original problem. We have one value of 0. So we plug that in. We do our math. Left-hand side, 0 plus 1 is 1. We get a square root of 1 equals 0 minus 1 is negative 1. The square root of 1 is 1. And 1 does not equal negative 1. Okay, this means x equals 0 is an extraneous solution. We still have to check the other one. Now, someone will argue this with me and tell me, but Mr. Linden, the square root of 1 can be negative 1. It can be. However, notice this radical says it's asking for the positive square root of 1. If it was asking for the negative square root of 1, they would have put a negative sign in front of the radical here on both sides of the problem. And it would have started that way over here. They would have had a negative sign in front of the square root of y plus 1. And they don't have that. So when we're checking, we are just left to simplify with what we have. Okay, so now we're going to check the second answer. We put in that y value of 3. Left-hand side gives us a square root of 4 equals, right-hand side is 2. Square root of 4 is 2. 2 equals 2. So that means that our only viable solution is y equals 3. Okay. I just realized I wrote this wrong. This needs to say y equals 0 over here. My fault. Sorry about that. Okay, so this one, although we solved it, we got two values for y at the end because we can solve it, and that happens. When we check those two values, the only one that's a solution is 3. So that is the only one that you would state if you were asked for solutions. All right, let's look at example 6 here. We square both sides. I want my blue pen back. It writes nicer. Square root of x plus 5 squared is x plus 5. Squaring x plus 3 is x plus 3 times x plus 3. It's going to give us x plus 5 equals x squared plus 6x plus 9. Be very careful with your double distribute. I've seen that cause a lot of grief over the years. Now we're going to subtract 1x from both sides. And again, notice I'm lining terms up. And we're going to subtract 5 from both sides because we got a quadratic when we double distributed. So I'm going to solve it and make it equal 0. It's going to give me x squared plus 5x plus 4. Now I know for a fact that there are factors of 4 that add up to 5. So I'm going to go right here and I'm just going to factor this into two binomials. X times x gives me x squared, and it has to be a plus 4 and a plus 1. Because that's the only way I'm going to get 4x and 1x to give me 5x, and 4 times 1 to give me the 4. Now I'm going to check my solution, or now I'm going to solve it using zero product property. So I've got x plus 1 equals 0, and I've got x plus 4 equals 0. So I've got an x equals negative 1, and I've got an x equals negative 4. So according to my math, these are my answers. But are they really my answers? I don't know. We have to check. We go back to that original problem. The square root of x plus 5 equals x plus 3. And it doesn't matter which of these you check first, ladies and gentlemen. I just start with the one I found first. So since I found negative 1 first, I'm going to put negative 1 in. I'm going to do my check. Negative 1 plus 5 is 4. Square root of 4 is 2. Negative 1 plus 3 is 2. So x equals negative 1 is a valid solution. Still got to check the other one. So we've got a square root of x plus 5 equals x plus 3. I put a negative 4 here, and I put a negative 4 here. I have a square root of 1 equals negative 1. The square root of 1, again, remember what I said earlier, we are simplifying what is here. We are not extrapolating any information beyond what's printed. So it says the square root of 1, which is 1. 1 does not equal negative 1. That means x equals negative 4 is an extraneous solution. Okay? And you'll notice both times I've had this happen, I've labeled which one the solution is and which one the extraneous solution is. That's going to help me when it comes time to take a quiz or take a test, because I have to make sure I understand which answer is which. I can guarantee you that there will be certain questions where it says what, or it just says solve. Okay? It's going to give you a radical function, or a radical equation, and you're going to be asked to solve it. Okay? The only solution you can state is the one that works. Okay? Now there will be some that say solve, state the extraneous solution. If that were the case, we only would state x equals negative 4 for this example, and we'd state y equals 3 for the first y equals 0 for the first example, because those solutions are the extraneous solutions. They're the ones that we get when we work out the problem that do not work when we check it. Now at this point, some kids typically think that, oh, look at that, these two examples, one answer worked and one answer did not. That's going to always happen. No, that is not going to always happen. I have encountered equations where both values work And I have encountered equations where both values do not work. Okay? So do not assume that when you solve a quadratic, one value works and one value doesn't. That is not the case. Each equation is dealt with independently, all right? So just make sure we have to check these answers, all right? There will be a book or practice assignment posted with this for you guys to work on.